In early 1943, the Allies faced an impossible problem. Deep in the industrial heart of Germany, in the Ruhr Valley, stood three colossal dams, the Mona, the Eder, and the Sorpe. These were not mere walls of concrete. They were man-made mountains, titans of engineering, that held back billions of gallons of water and powered the German war machine. Destroying them would cripple steel production and flood a vital industrial region. But they were considered indestructible. Conventional bombs would barely scratch their surface. Torpedoes were useless, blocked by massive underwater nets. The dams were fortresses, immune to any weapon in the Allied arsenal. To defeat them, it would take a weapon that didn't yet exist, born from an idea so absurd, so counterintuitive, that it was initially dismissed as madness. It was an idea inspired by a child's game, skipping stones on water. The man behind this madness was Barnes Wallis, a brilliant, obsessive, and often difficult British aircraft designer. Wallis was not a typical military engineer. He was a visionary, a man who saw solutions where others saw only problems. He was already famous for the geodetic airframe of the Wellington bomber, a crisscrossing lattice structure that made the aircraft incredibly strong yet lightweight. But Wallis was haunted by the limitations of conventional bombing. He saw that dropping bombs from high altitude was a terribly inaccurate and inefficient way to destroy a precise, hardened target. He became obsessed with the idea of creating a perfect bomb, a weapon that could strike with surgical precision and overwhelming force. His mind turned to Germany's dams, the ultimate hardened targets, and he began to formulate a plan. Wallis's initial concept was a gargantuan, 10-ton earthquake bomb dropped from 40,000 feet that would pierce the earth and create a seismic shockwave to shatter the dam's foundations. The RAF, however, had no bomber capable of flying that high with such a heavy load. The military establishment viewed Wallis as an eccentric dreamer, his ideas impractical. Frustrated but undeterred, Wallis went back to his first principles. He knew that the most effective way to destroy a dam was not to attack its face, but to place an explosive charge directly against its base, deep underwater. The pressure of the water would then contain the blast and focus all its energy directly into the structure, shattering it from the inside out. But how could he get a bomb there, past the torpedo nets? The answer, he realized, didn't lie in going through the water, but over it. The legend, confirmed by his daughter, is that the eureka moment came in his own backyard. While playing with his children, Wallis began skipping marbles across a tub of water. He noticed that if he gave the marble backspin, it would hug the surface of the water, traveling much further before sinking. In that simple observation, a revolutionary idea was born. What if a bomb could be designed to do the same? A cylindrical bomb dropped from a low altitude and given a powerful backspin would not plunge into the water. Instead, it would skip across the surface like a stone, bounce over the defensive torpedo nets, and, upon reaching the dam wall, use its remaining forward momentum to cling to the concrete as it sank. The backspin would press it tight against the dam's face, ensuring it reached the perfect detonation depth at the foundation. When Wallis presented this idea to the military authorities, the reaction was, predictably, one of disbelief. It sounded like something out of a science fiction novel. A skipping bomb? It was absurd. But Wallis was relentless. He conducted countless experiments, first with models in his garden water tank, then with larger prototypes at the National Physical Laboratory. The challenges were immense. The bomb had to be a perfect cylinder. It had to be dropped from an exact, suicidally low altitude of just 60 feet. It had to be flying at a precise speed of 240 miles per hour. And it had to be spinning backwards at exactly 500 revolutions per minute. Any deviation, and the bomb would either plunge too deep, bounce too high, or disintegrate upon impact with the water. The trials were fraught with failure. Bombs made of wood shattered. Steel casings buckled. The physics was unforgiving. But slowly, through brutal trial and error, the design was perfected. The final weapon was codenamed Upkeep. It was a giant 9,000-pound steel cylinder, looking more like an industrial water heater than a bomb. To achieve the crucial backspin, a special motor was installed in the bomb bay of a modified Avro Lancaster bomber. Just before release, this motor would spin the bomb up to 500 RPM. The bomb itself was held in place by a pair of V-shaped calipers. Dropping it was a matter of simply opening the calipers and letting it fall. The modified Lancaster was a marvel of its own. The bomb bay doors had to be completely removed, leaving the massive spinning cylinder exposed to the airstream. The extra weight and drag made the plane incredibly difficult to fly at the required low altitude. While Wallis was perfecting his weapon, the RAF was tasked with finding the men who could wield it. In March 1943, a new, top-secret squadron was formed, No. 617 Squadron. It was composed of the best and most experienced bomber crews from across the Commonwealth. Its commander was a 24-year-old flying prodigy, Wing Commander Guy Gibson, already a veteran of over 170 missions. He was a brilliant pilot and a strict, demanding leader. He was told only that his new squadron had a secret, critically important mission, and that they had less than 2 months to prepare for it. The nature of the weapon and the target were kept a closely guarded secret, even from the pilots themselves, until the final days. The training for 617 Squadron was the most intense and dangerous of the entire war. The pilots had to learn to fly a massive 4-engine Lancaster bomber as if it were a nimble fighter. Their lives depended on maintaining an exact altitude of just 60 feet above the water at night. Flying any higher and the bomb would shatter on impact. Flying any lower and the plane's own propellers would hit the water, causing a catastrophic crash. To solve this problem, a brilliantly simple solution was devised. 2 spotlights were mounted on the aircraft, one under the nose and one under the fuselage, angled so that their beams would converge into a single spot on the water's surface only when the plane was at the perfect 60-foot altitude. The pilot's job was to fly so low that these 2 spots of light became one. But altitude was only half the problem. The bomb had to be released at a precise distance from the dam wall. Standard bomb sights were useless at this low altitude. The solution, again, was wonderfully simple. The squadron's navigator, Flight Lieutenant Harrow, Danny Walker, created a handheld targeting device made from a wooden triangle and a piece of string with a peg at each end. The pilot would look through a peephole, and when the 2 pegs on the string lined up perfectly with the towers on either end of the dam, he knew he was at the correct release distance. The lives of the crew, the success of the mission, and the fate of the bouncing bomb depended on a piece of wood and 2 spotlights. It was the ultimate marriage of high-tech weaponry and low-tech, improvised genius. On the evening of May 16, 1943, the mission, codenamed Operation Chastise, was a go. 19 modified Lancasters, each carrying 1 spinning cylindrical bomb, took off into the night. Their flight path was a suicidal low-level dash across Holland and into Germany, flying at treetop height to avoid German radar. In the final briefing, Guy Gibson revealed the targets. For the first time, the crews saw the photographs of the massive Mona, Eder, and Sorpe dams. Gibson's final words to his men were stark. "This is going to be a sticky trip, but if we can pull it off, we'll make history." The flight in was a battle in itself. Flying at less than 100 feet, they had to navigate by map and compass, dodging high-tension power lines and German flak towers that fired down at them from above. 2 Lancasters were lost before they even reached the target area. Just after midnight, Gibson's formation arrived at the first and most important target, the Mona Dam. It was a terrifying sight, a colossal wall of stone and concrete, heavily defended by anti-aircraft guns. Gibson went in first. He brought his Lancaster down to the shimmering surface of the reservoir, lining up the dam's towers in his wooden sight, his co-pilot calling out the altitude as the two spotlights converged. Down a bit, steady, steady. Flak tracers ripped through the air around them. At the perfect moment, Gibson shouted, "Bomb gone!" The crew felt a lurch as the 9,000-pound weapon was released. They watched as the bomb hit the water, skipped 4 or 5 times in enormous splashes, hit the dam wall, and sank. A few seconds later, a colossal plume of water erupted behind the dam, but the wall held. The next plane went in. It was hit by flak and exploded in a massive fireball. The third plane, flown by Squadron leader Dingy Young, made its run. Again, a perfect drop. Again, a massive explosion. The dam was now clearly damaged, water pouring over the top, but it still had not broken. It was now the turn of Squadron leader David Maltby. As he made his run, the German gunners threw everything they had at him. His aircraft was hit multiple times, but he held it steady. He released his bomb. It skipped perfectly, hit the weakened section of the wall, and sank. There was a pause, and then a cataclysmic explosion. The center of the Great Moni Dam seemed to lift into the air and then disintegrate. A torrent of water, a 30-foot-high tidal wave, began to pour into the valley below. Gibson, circling overhead, transmitted the triumphant prearranged code word, "nigger." It was the name of his beloved black Labrador, and it meant the dam had been breached. With the Monet destroyed, Gibson led the remaining bombers with live weapons on to the next target, the Ader Dam. The Ader was less defended, but nestled in a deep, winding valley, making the approach incredibly difficult. The pilots had to make a steep banking turn at just 60 feet to line up for the drop. It was a feat of almost superhuman airmanship. After several harrowing runs, the Ader Dam was also breached, unleashing another devastating flood. The third target, the Sorpe Dam, presented a different problem. It was an earthen dam, not a concrete gravity dam, making it less vulnerable to the upkeep bomb's specific blast effect. Several planes attacked it, but while it was damaged, it was not breached. The mission was a partial but spectacular success. But the success came at a terrible cost. The flight back was just as dangerous as the flight in. Of the 19 Lancasters that had set out, 8 did not return. 53 highly skilled and incredibly brave airmen were killed. 3 more were captured. The casualty rate for the mission was a staggering 42%. 617 Squadron had made history, but they had paid an almost unbearable price. When the survivors returned to their base at RAF Scampton, the mood was a somber mix of elation and profound grief. Guy Gibson was awarded the Victoria Cross, Britain's highest medal for gallantry, and 33 other crew members were also decorated. The Dambusters, as they were immediately christened by the press, became legends overnight. The immediate aftermath of the raid was devastating for Germany. The breaching of the Möhne and Eder dams unleashed nearly 330 million tons of water into the Ruhr and Eder valleys. The resulting flood wave was a destructive torrent. It swept away bridges, destroyed factories, inundated coal mines, and wiped out power stations. For a critical period, industrial production in Germany's most important industrial region was severely disrupted. The psychological impact on the German leadership was equally profound. They had believed their dams were invincible. The raid proved that no target was safe from the reach of Allied ingenuity. Albert Speer, Hitler's armaments minister, called the raid a disaster of the first magnitude and diverted over 20,000 workers from building the Atlantic Wall to repair the dams, a critical diversion of resources in the year before D-Day. However, the long-term strategic effectiveness of the raid remains a subject of intense historical debate. The Germans, with their characteristic efficiency, repaired the dams with astonishing speed. Within a few months, the power stations were back online and the water supply was restored. Some historians argue that the raid, while spectacular, did not cause the lasting damage that was hoped for, and that the horrific loss of 53 elite airmen was too high a price to pay for a temporary disruption. They argued that the resources and skill of 617 Squadron would have been better used in the ongoing, grinding campaign against German cities and industry. It's a debate that highlights the difficult choices of war. Is a single, spectacular, morale-boosting victory worth more than a slow, attritional campaign? But what is not in dispute is the raid's legacy as a story of incredible innovation and human courage. It was the ultimate triumph of the unseen front. It proved that a single, brilliant, and stubbornly persistent engineer like Barnes Wallis could change the course of a battle. It proved that a crazy idea, born from a simple observation, could defeat a mountain of concrete. And it proved the astonishing skill and bravery of the air crews, who were asked to fly into the face of death, armed with a piece of wood, 2 spotlights, and a spinning, skipping 9,000-pound bomb. The story of the Dambusters became a powerful symbol of Allied ingenuity, a legend that boosted morale at home and sent a clear message to the enemy. There was no problem that couldn't be solved, no fortress that couldn't be breached.